This is homework problem number 1 in Chapter 4. It is a problem which asks you to analyze this truss using the method of joints. First thing, of course, that you want to do is find the support reactions. In this case, RAV and RCV are 1,250 pounds apiece. We also want to identify what the angle of the diagonals are. In this case, both diagonals are set in space by 15 feet vertical and 10 feet horizontal, giving an angle of 56.3 degrees. Moving on to joint A. A free body of joint A will have the 1,250 pound reaction. You have two unknown joint forces, AB and AD. You can see AD is broken down into an X and a Y component. Writing the equations of equilibrium in the X direction, we find that AB plus AD cosine 56.3 degrees is equal to 0. Can't solve that, so we move on to the Y direction equation equals 0. Solving for AD, we find out that AD is equal to a negative 1,502 pounds. Now the negative means that AD acts in the opposite direction. Notice in my free body I had the components acting away from the joint, but in essence the negative means that AD acts back into the joint. I can then take the AD of negative 1,502 pounds, substitute it into the X direction equation, and solve for AB equal to 833 pounds. I can then place those forces up onto the big picture. I can then flip-flop AB and AD down to the other end of the member. Moving on to joint B, I have the 500-pound force hanging off joint B. I also know the AB joint force of 833 pounds, which I got from solving joint A. That leaves me two unknowns. I can write the X equation and solve for BC is equal to 833. I can write the Y equation and I can solve for BD is equal to 500 pounds. Notice in both cases that the answers to the unknown are positive. That means the way that I had assumed the directions acting on the free body are correct. I can then put those forces onto my big picture, and then I can make sure that I flip-flop those forces down to the joint at the other end of each member. Moving on to joint C, which will be our last joint that we'll have to solve something for, I can draw my free body of joint C. Again, I know the reaction of 1,250 pounds, and I know the 833 pound force on BC that I found from solving my last joint, joint B. That gives me one unknown, which is CD. You can see here I've broken CD down into an X and a Y component. Since there's only one unknown, I should be able to solve this using just one equation. I write the X equation, and in that case I can find that CD is equal to a negative 1,502 pounds. Again, negative means that it acts in the opposite direction from what I had assumed. I had assumed that the X and the Y component acted away from joint C, but the negative actually indicates that it acts towards joint C. Towards the joint means compression. Away from the joint means tension. So there I've solved for all my unknowns. Now if you did want to come back and solve for joint D up here, you have all the forces known, but you can solve it as a check because the sum of all the forces in the X and in the Y direction should come out to be equal to 0.